Hey Science 20s, it's time to talk about how to move one type of mole to the other. Now, if you're in my class, this is I'm speaking Mr. Zakowski, you've done this already. Mr. King's class has not done this. So this is a good review for everybody. A mole is a chemical amount, and we can convert one mole to another mole quite easily in chemistry because moles is basically a fancy way of saying the number of atoms or particles. So you can, because particles and atoms don't go anywhere in a chemical reaction, we can use it to compare one side to the other. First, we need to double check that the reaction given to us is balanced, and it is. And then we're going to write down what we know. It says we need to solve the number of moles of silver. So I'm going to go question mark mole. MOL is the short for mole. And I'm going to go 8.2 mole of zinc. Now, in your textbook, when you're converting one type of mole to the other, and in your data booklet, there's a little ratio. And the formula looks like this. NR is equal to Ng times the coefficient of R times the coefficient of G. N is number of moles. So what we're trying to find is the number of moles of the required. The thing that we're required to solve is this. That is our required. And the number of moles is the one that's given to us. So this is our G. So what we do is we go 8.2, that's Ng, and we times it by a ratio. The coefficient for the R is right here, 2. And the coefficient for the G, we don't have one, so it's 1. So 8.2 times 2 over 1 is 16.4 moles. So that's the formula way. Now, the other way that I taught my class is draw an arrow to where you're going. That's the number that goes on top of the fraction. So I'm drawing an arrow over here. The 2 is where we're going. Where did we come from? A 1. That's the ratio between the two. So you can move one type of mole into another type of mole. Okay, let's try another question. How many moles of ammonia is made from 4.2 mole of hydrogen? Okay, so that's the question. Now, you'll get the reaction, so you don't need to worry about this part. I'm just giving you the reaction that we're going to be using. Okay, first off, we need to see if it's balanced, and it's not. It looks like the hydrogens and nitrogens are out. We have 3 and a 2 there, so let's put a 2 there to make 6, and a 3 there to make 6. Now we're good. Okay, so it's wanting number of moles of ammonia, question mark. And it's made from 4.2 moles of hydrogen. 4.2 mole. Okay, so using that formula, we're going to go 4.2 times the required over the given. The thing that we're trying to solve is always our required. So I'm going to put a 2 on top, and the thing that we've been given that goes on the bottom, the coefficient. So we go 4.2 times 2 divided by 3. Now, if anybody's had me, you know I'm not great at mental math, so times by 2 divided by 3, I get 2.8 mole. And again, if we use my arrowed method, times by where you're going, 2, divide by where you've been, 3, 2 over 3. Okay, so that's moving one type of mole into another type of mole.